Welcome back to Dissolve Chemistry, dear students. This video is exclusively for the students, those who have written Karnataka State CET examination. I hope all of you have done all the papers well. So let us discuss chemistry paper. In my hand I got with set B3. Okay, so we'll solve the questions one by one. Please go through that and check your answers either correct. Okay, so let us start with first question. Well, the first question is, in the analysis of 3 group basic radicals of salt, the purpose of adding ammonium chloride to ammonium hydroxide is, A option is to increase the concentration of the OH ions, and B option is to precipitate the radicals of group 4 and 5, and the third option is to suppress the dissociation of ammonium hydroxide, and fourth option is to introduce chloride ions. And your right option is C. Okay, how it is and what is the purpose of adding ammonium chloride is, you know that ammonium hydroxide is a weak base, okay, and it ionizes partially, and as it furnishes OH minus ions, these OH minus are more than sufficient, okay, to precipitate group 3 radicals. Okay, so that is, as it is access to precipitate group 3 radicals, if excess of OH minus is present along with this group 3 elements, other group elements are also be suppressed. So to avoid that, what you have to do, you have to suppress the ionization of ammonium hydroxide. To suppress the ionization of ammonium hydroxide, we have to use the salt which is having common ion with this, and that salt is ammonium chloride, which is strong electrolyte, hence it will give ammonium cation. Excess of ammonium cation will suppress the ionization of ammonium hydroxide. Let us move on to the second question. Already the second question is, the solubility product of calcium oxalate at a given temperature in pure water is 4 into 10 to the power minus 9 mole per liter square. Okay, solubility of same calcium oxalate at the same temperature is, that is our question, and the options are given as 6.3 into 10 to the power minus 5 mole per liter, 2 into 10 to the power minus 5 mole per liter, 2 into 10 to the power minus 4 mole per liter, 6.3 into 10 to the power minus 4 mole per liter. So here, if you won't even remember the formula, so what hint you are going to get is that here the unit is square. So therefore the answer is under root of that. So therefore you can write like this: solubility product square is equal to 4 into 10 to the power minus 9. So therefore solubility is equal to under root 4 into 10 to the power minus 9. Okay. So now what you can do is, you can take it 4 under root 4 one side, and into you can make out 10 to the power minus 9 by 2. Okay. So when you simplify this, you are going to get answer 6.3 into 10 to the power minus 5 mole per liter. So therefore your option is A. Okay, I hope you have understood how you have to solve this question. Okay, so let us move on to the next question, that is third question we will take. Okay, the third question is, the reaction between moist SO2 and acidified permanganate solution gives what? Okay. Here you should look into the options what are being given. On that only we can make out. One is, here in this SO2, the oxidation state of sulfur is plus 2, and here it is plus 6. Okay, here it is plus 7, it is plus 2. Okay, and you should remember permanganate is a strong oxidizing agent in acidic medium. So therefore here there is a scope for undergoing what? Oxidation, isn't it? So therefore when you look into the options, so the first option is SO2 is oxidized to SO4 minus 2, and MnO4 is reduced to Mn plus 2. Okay. The second option is SO2 is reduced to sulfur, and MnO4 minus is oxidized to MnO4. Okay. Here there is no change in the oxidation state of Mn in both the cases. Okay. And it cannot go beyond plus 7, so therefore it is plus 8. So therefore it is not possible. This option is wrong. Okay. Then the third one is, SO2 is oxidized to SO3 minus 2. So here you can see the oxidation state of sulfur in both the cases. Here it is plus 4, here it is also plus 4. So therefore there is no oxidation, you can say. Okay, then this option is also not right. So then here you can see SO2 here +2, and here it is going to the -2 oxidation state, but it's a good oxidizing agent, it cannot reduce it. Okay, so therefore your D option is also not correct. So therefore your right option is A option. Okay, so like that also you can identify the answer, right? So let us move on to the next question. Fourth question is, which one of the following property is generally not applicable to ionic hydrides? Let me clear you what is ionic hydrides. You can take like sodium hydride, okay, or you can take lithium hydride, okay, and these are all called as what? Ionic hydrides. And if you take hydrates like water, these are all called as what? Water, CH4, okay, HF, all these are what? Covalent hydrides. Okay, so what he is saying, which is not applicable to ionic hydrides. Okay, so one is non-volatile. Of course, these are solids, these are non-volatile, and non-conducting in solid state. All ionic compounds generally they are non-conducting in solid state. Molten state they can conduct. Okay, and the third option is they are crystalline solids. Of course, they are crystalline solids. And the fourth option is volatile. You can see these covalent compounds are volatile, covalent hydrides, but ionic hydrides are these are not non-volatiles. Okay, so these are non-volatile compounds. So therefore your option will be what? D, which is not applicable for ionic hydrides. They are not volatile compounds. Fine. So let us move on to the next question. Okay, the next question is, which one of the following nitrate will decompose to give NO2 on heating? Okay, so the options given are sodium nitrate, potassium nitrate, rubidium nitrate, and lithium nitrate. All are the nitrates of the alkali metals. So therefore you should remember that. So this lithium nitrate, okay, upon heating it forms lithium oxide plus NO2 gas is being liberated. Okay, then your option is D is the right option. Fine. So let us move on to the next question. Okay, which one of the following halide cannot be hydrolyzed? Okay, when you look into all these halides, all are of carbon family halides, we can say carbon, silicon, germanium, and tin chloride we have. So you see here, as you move down, what happens? Carbon to silicon, silicon to germanium, germanium to titanium. So what you will be seeing? Sorry, tin. So you will be seeing the increase in the metallic character of these elements we are going to see. So therefore, this carbon tetrachloride is more covalent in character. Okay. So therefore, it cannot be hydrolyzed. CCl4. Okay. The right option is A. And rest will be having what? So we can partially, they can undergo hydrolysis, but this particular will not undergo any hydrolysis because it is purely covalent in nature. Okay, let us move on to the next question. Seventh question we will take. So the question is, 0.48 gram of an organic compound on complete combustion produces 22 grams of CO2. The percentage of carbon in the given organic compound is, it is the question. Okay, so let us solve and find the answer for this, right? See here, one thing you should remember, carbon dioxide molecular weight is 12 plus 32, so that turns out to be 44 grams. 44 gram of CO2 corresponds to how many grams? 12 grams of carbon. Okay, and the second thing is that how much gram you got with? 22 grams, right? So therefore that is X gram of carbon. So therefore X gram is equal to, so 0.22 grams into 12 grams, okay, divided by 44 grams, it will give you the amount of the carbon in terms of grams. Okay, so therefore that if you want to express in terms of a percentage, then what you have to do? You have to multiply this with 0. How much amount of the compound you have taken? 0.48 grams of the compound, organic compound is taken, okay, into 100 you do. So then, so you will be getting answer as, okay, X gram or X is equal to X in terms of percentage if you take. So then you will be getting what? 12.5 is the answer. Okay, and your right option is C. Okay, let us move on to the next question. The next question is, in the given sequence of reaction, identify P, Q, R and S respectively. Okay, the first compound you have taken is ethene. Ethene is converted into vicinal dihalide, that is 1,2-dibromoethane, and 1,2-dibromoethane converted into once again bromoethene. Okay, and that bromoethane again converted into acetylene, acetylene into benzene. Okay, so this conversion, as you see that a bromine molecule is being added to ethene, so therefore your B and C option automatically what? So you have to neglect those options, and now remains A and D. So the next thing is 1,2-dihalide we are going to get, and again selectively dehydrohalogenation is being done to get bromoethene. And in the second step, if you want to dehydrohalogenate in the second step, already it is alkene, it is very difficult, so therefore we are using a very strong base like a sodamide. Okay, NaOH is not sufficient here, we have to use still more stronger base, that is sodamide we are going to use, and then we are going to ending with acetylene. And this acetylene, 3 moles of acetylene, if you heat in a red hot iron tube, so then you are going to get benzene. So therefore your option is what? D option. Okay, so let us move on to the next question. The first insecticide, a chlorinated organic insecticide prepared is, options are gamexane, chloroform, okay, COCl2 and DDT is given. Memorizing question, memorizing type of question it is, so therefore your option is DDT. Okay, so let us move on to the next question. Well, this 10th question, it is again on solid state. Solid state, of course, it is not there in the syllabus, out of syllabus. I don't know that either they are going to give you bonus marks or what. Let us see that one. And 11th question is also going to belong to the same solid state, but still MnO it is given, manganese oxide. Okay, exhibits what? So like that the question is being asked. MnO exhibits what type of magnetic property? That is ferrimagnetism, A option. B option is anti-ferromagnetism, and C option is ferromagnetism, and D option is paramagnetism, and the correct option is anti-ferromagnetism. Of course, this question is from solid state, but we don't know that if it is considered as D and F block question, so then we have to consider it. So therefore, please make note of this. The answer is anti-ferromagnetism, option B. Okay, and 12th question is also once again it is from solid state only, which is again out of syllabus for this year, right? So therefore directly we will move on to the 13th question. Okay, vapor pressure of solution containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius is, okay, so how much lowering of the vapor pressure has taken place upon addition of 18 gram of glucose to 178.2 grams of water at 100 degrees Celsius, it is being asked. Okay, and the vapor pressure of pure water at 100 degrees Celsius is given as 760 torr. Okay, one logically how you can answer this question is that 760 torr is the vapor pressure of the water at 100 degrees Celsius. At same temperature, when you add glucose to what it is going to reach, so then you should see the value 76.0 torr, means it is almost 10 times less than that. So that much lowering of the vapor pressure you won't observe by addition of merely just 18 gram of glucose. Okay, and then you move on to the next option, that is 752.4 torr. Okay, it is near to that. Okay, so therefore we can consider this, but still we will not agree with this. Okay, let us move on to the 7.6. again it is, or 100 times it is less than this, so then it is very large, it is not possible lowering we are seeing, so it is higher one, so therefore this is not the right option. So 1, 2, 3 we have to neglect A, C and D, probably B, so we will calculate and we will confirm this one, right? So we know that one, P naught minus Ps divided by P naught is equal to mole fraction. Okay, mole fraction of the solute B you can take. So mole fraction, you know that one, NB by NB plus NA, that is, it is solvent. You can write directly water, and here you can write it as glucose, and here you can write it as glucose. Okay, we will make it the formula. Fine, 760 torr minus PS, we are expected to find the vapor pressure of the solution, right? Divided by P naught is again 760. So which is equal to number of moles. So we know that 18 grams it is given, divided by its molar mass is 180, glucose molar mass, divided by, okay, so again it is 80 divided by 180 gram plus water, how much it is given, approximately you can take 178.2 divided by, sorry, 178.2 divided by how much, 80. Okay, so it comes around 99 point something, it comes around, and if you simplify this, you will be getting answer as 752.4 torr. Okay, so therefore we can confirm this answer as 752.4 torr. Okay, so logically you can try, but we should confirm with this also. Fine. All right, the 14th question is a mixture of phenol and aniline shows negative deviation from Raoult's law. This is due to formation of, is the question. Okay, so negative deviation means, so the vapor pressure is lower than expected for ideal solution. So therefore that can happen when the molecules get associated with one another. Okay, so that association, when it is possible, you can see here, I will write the structure of both the compounds that phenol is. Okay, so this is how the intermolecular hydrogen bonding is going to exist between phenol and aniline. So because of that reason, what happens, it is going to show negative deviation, means one molecule is attracting another molecule and it is not allowing to undergo vaporization. So therefore your right option is C option, that is intermolecular hydrogen bonding. Intra, it is given, intra it is not possible because only one OH group and only one aniline group, and that is not going to affect it. Non-polar, covalent bond, polar covalent, these are all not required. Fine. Let us move on to the next question, that is 15th question. Again, it is again on the Raoult's law itself. Fine. So which one of the following pair will show the positive deviation from Raoult's law? The question is. Okay. So you'll see the options and then you solve. Okay. So what it is asked? Positive deviation from Raoult's law. Okay. Exactly, if you are not remembering the answer what it is, at least we can neglect and we can try to get the answer. Fine. The first thing is water HCl. HCl is having a very good affinity for water, so therefore it cannot show the positive deviation, means molecules should repel with each other, then vapor pressure will be greater than what we expect for ideal solution. Fine. So therefore there is an associative relationship between water and HCl you find. Okay. I don't know, benzene, methanol, it is going to show positive deviation. Still we will try to get that one from looking into other options. Water and HNO3, again it is a acid, so therefore it is having affinity for water more, so therefore it is having associative behavior with water. Then when you look into acetone and chloroform, they are going to form hydrogen bond, so therefore they are also showing associative behavior. Means all the three options, whatever you see, so all those three options we are going to see, they are all showing associative behavior, means all are showing negative deviation, means your right option should be your B, that is benzene and methanol. Literally I am also not remembering that benzene and methanol, but by neglecting all these wrong answers we can find this as a right answers, and your right answer is benzene and methanol, which is going to show positive deviation from the Raoult's law. Okay, let us move on to the next question. So how many coulombs are required to oxidize 0.1 mole of water to give oxygen? Okay, so we know that, so each water molecule, 1 mole of water molecule to oxidize. Okay, so 2H plus a half O2 plus 2 electrons are being released. Okay, so we need to oxidize, we need 2 electrons. 1 mole it's a 10 times less than that. 0.1 mole means 1 by 10 moles of water. Fine. So we know that number of electrons into Faraday, the total charge required, number of electrons are 2. Okay, fine. And into Faraday for 1 mole, right? So therefore 96500. Okay, and then how many moles it is? 1/10 of the mole it is given. So therefore what you have to do? You have to divide the answer by 10. Okay, so you do it. So therefore your answer comes out to be 1.93 into 10 to the power 4 coulombs. Okay, and your right option is B option. Okay, so let us move on to the next question. A current of 3 ampere is passed through a molten salt, calcium salt, for 1 hour 47 minutes 13 seconds. The mass of calcium deposited is, okay, molar mass of calcium is given as 40 gram per mole. So therefore how you have to solve this question is that so Q is equal to I into T. The current transferred is 3 ampere and time you have to take as 1 hour means 3600 seconds into 47. Okay, 47 into 60 we will make 0. Okay, so therefore plus 2820 plus 13 seconds. Okay, so if you do this, what you are going to get? 3346. Okay, so when you multiply this with 3, what you will be getting? 9, 9, 12, 1, 19. Okay, so this much amount of the coulomb of the charge is being passed through the solution. Okay, then how much you are going to get calcium is going to get deposited. So we know that to deposit 1 mole means 40 gram. 40 gram is going, calcium is being deposited when the current is passed as what? 96500 coulombs of the charge if you pass. So then you will get 40 grams of deposition of the calcium. So now 19299 coulombs of the charge, okay, when you pass, then how many grams it is going to deposit? So therefore 19299 into 40, so divided by 96500. Okay, so you will be getting 4 grams. Okay, so that is your amount of the calcium deposited. So your option is D option. Fine. So let us move on to the next question. The value of A in the given equation lambda m is equal to lambda naught m minus A into under root C, okay, is same for the pair it is given. Okay, so what is this? Molar conductance, and it is molar conductance at infinite dilution, and under root C is the concentration. How the with concentration it is going to vary, and you should remember this A is a constant, and this A depends upon the stoichiometric coefficient, right? So in the following pairs which are having stoichiometric coefficient of the ions is same, so that will be our answer. You can see here it is Na plus Cl minus. Here we are going to get how many number of ions? 2, and here we are going to get 3. So stoichiometry is what? Different in this case. Okay, so here also the same thing will happen. So here you will get 3 ions, and whereas here we are going to get 2 ions, and here also you can see 3, here 1 or 2 ions we are going to get, but in this case we are going to get 2:2. So stoichiometric coefficient in both the salts is same. So therefore A value for the given pair of the salts is same for both are strong electrolytes, you should remember, and this constant A will be what? Same in the case of NaCl and KBr. Your option is C option. Okay, so let us move on to the next question. Okay, the next question is for the reaction of A, B, both are equilibrium is being attained between the A and B. Energy of activation is given as 50 kilojoules per mole and delta H is minus 20 kilojoules per mole. And when the catalyst is added, EA decreases by 10 kilojoules per mole. What is the EA for the backward reaction in the presence of catalyst? The question is being asked. Okay, so to understand this, simple we will do. So you draw a graph for this energy, and this is a reaction coordinate. So what you will be seeing, right? It is a reversible reaction, you should remember. Reversibly gives B. Okay, it attains an equilibrium. Now A got converted into B, right? So now this is the energy of activation. So we will take up to here. Okay, this is what? 50 kilojoules per mole. Kilojoules per mole. Fine. And when you add the catalyst, you should remember catalyst, what it does, it will reduce the energy of activation. Okay, it will not shift the equilibrium. If you go through the factors affecting equilibrium, there you can see that only it will make the equilibrium to attain faster. Okay, but it will not alter what? Equilibrium concentration. So therefore, so what it is going to do, so you will be having energy of activation from here to here, that is your 10 kilojoules is less. Okay, so 10 kilojoules is being reduced. So therefore your energy of activation EA is equal to 50 kilojoules initially, minus when catalyst is being added 10 kilojoules is being reduced. So therefore it comes out to be 40 kilojoules. And energy of activation, when it has attained an equilibrium, the energy of activation of conversion of B to A or A to B will be same. So therefore for reverse reaction is also it is 40 kilojoules, and your option is B. Okay, I hope you have understood this one. Okay, let us move on to the next question. Okay, the question is for the reaction PCl5 undergoes dissociation to give PCl3 and Cl2. The rate of rate constant are 1.02 into 10 to the power minus 4 mole per liter per second and 3.4 into 10 to the power minus 5 per second respectively. At a given instant, the molar concentration of PCl5 at that instant is, okay, you are given with the rate as well as a rate constant K. Okay, so therefore what you have to do is very simple. So you take say for example rate is equal to K into PCl5 raised to the power 1. Why? It is a first order reaction that we can see from the unit of the rate constant per second. Okay, so now what you do, what we want molar concentration of the PCl5. So therefore molar concentration of PCl5 is equal to K rate divided by K. Okay, you substitute the values. Okay, what is that? 1 point rate is 1.02 into 10 to the power minus 4 divided by 3.4 into 10 to the power 5. Okay, so it turns out to be, your answer turns out to be 3. Okay, and 3 mole per liter. The concentration of PCl5, just simplify, you will get this answer, and your option is B option. Okay, so let us move on to the next question. Okay, your question is which one of the following does not represent Arrhenius equation? Okay, so you see here only by looking into these equations we can make out. The thing is here A into e to the power minus Ea by RT is going to represent what? K is equal to, so your Arrhenius equation, and here you can see that it is plus Ea by RT. So by looking into the sign of this, we can assume as what? D is the right option. This is not going to represent the Arrhenius equation. Fine. So the next question is, it is again out of syllabus, 22nd question. Make note of this. It is from colloids, that is surface chemistry, and your 23rd question is also from the surface chemistry. It is also out of syllabus. Please make note of these questions. And next question is again gold soul is not, okay, again it is also 24 is also what? Out of syllabus you can consider. And Hall Helot process, that is metallurgy question. 25th is also from metallurgy. It is also out of syllabus. And next question is 26th question. Again it is also from metallurgy. Okay. So therefore 26th question is also not in the syllabus. So therefore you leave that also. Okay. We will move on to the next question, that is 27th question. The question is NO2 gas is, your option is given. 27th question, NO2 gas is your question. Okay. So first one is colorless neutral, colorless acidic. You should remember it is a brown, reddish brown color fumes it will be. So therefore, and it is a slightly acidic. So therefore brown acidic is your right option. Okay. So C option is the correct option we can take. Okay. Right. Just I will read out. Okay. Just I will read out the options and just try to make out of this. Oxides of nitrogen in the atmosphere cause depletion of the ozone layer. And B option is ozone absorbs the intense ultraviolet radiation from the sun. And the third option is depletion of ozone layer is because of chemical reaction with chlorofluoroalkanes. Yes. And D option is ozone absorbs infrared radiations. Okay. C, remember, ozone absorbs UV radiations, ozone absorbs IR radiations, and depletion occurs due to chlorofluorocarbons. Therefore, your option is A option, that is oxides of nitrogen in the atmosphere can cause depletion of the ozone is the incorrect statement, and your option is A option. Okay, please make note of this. Next is 29th question. Okay, so we will write this one. CL. Okay, so it is a memorizing type of question. So therefore, your answer is your C option. Okay, so the boiling point of, right, the correct decreasing order of boiling point. The highest boiling point is of hydrogen fluoride, because we can see the profound hydrogen bonding in this case. So then followed by hydrogen iodide, hydrogen bromide, and HCl. Okay, so this is the right option you should make out. Well, the synthetically produced radioactive gas by the collision of 249 californium with 48 calcium is radon, radium, agason, and xenon, and your right option is C, that is agason is going to be produced when both are being collided with each other. Okay. Let us move on to the next question, that is 32nd question. All right. So when you look into these ions, what we can see is, first you should go through the nickel one, because its atomic number is 28, plus 2 oxidation means number of electrons in the D subshell will be what? 8, D8 configuration. And zinc, you know that one, it is a non-transition element, even though it is a D block element. Hence, it is not going to exhibit color, so therefore it is colorless. And the 1.73 Bohr magneton, okay, it is given with respect to your copper. So therefore, nickel corresponds to D8 configuration. Then zinc corresponds to colorless, and your copper corresponds to what? 1.73 Bohr magneton, right? So which is that option? Let us see. 1 to 2. Okay. 1 to 2 and 2 to 3. Yes. And 3 to 1. So therefore your option is B. Okay. So let us move on to the next question. 33rd question. Okay. So it's a theoretical question. Just I will read out. Which of the following statement related to lanthanoids is incorrect? Okay. Once again I will read. Which of the following statements related to lanthanoids are incorrect? The first option is lanthanoids are silvery white soft metals. Of course it is correct. And second one is samarium shows +2 oxidation state. Of course it will show because it is not a common oxidation state, but still it is going to exhibit this one, not a stable state. Then next is cerium +4 solutions are widely used as oxidizing agent in titrimetric analysis. Of course it is also correct. It is used in titrimetric analysis of various as a oxidizing agent, right? And D option is color of lanthanoid ion in solution is due to DD transition. DD transition occurs in D block elements. Lanthanoids are F block elements. So therefore the color arises in lanthanoids due to FF transition. So therefore the D option, color of lanthanoid ion in solution is due to DD transition, is the correct option. Okay. 33 question number option is D. Okay. So what is the question? 100 ml of 0.1 molar aqueous solution of the complex, okay, chromium chloride hexahydrate with excess of silver nitrate, 2.86 gram of AgCl was obtained. Precipitate we are going to get. And then what is the complex? It is a question on Werner's theory. Okay. And we are going to predict that how many number of chloride ions are there in the coordination sphere, or number of chloride ions in the ionic sphere. Okay. So ionization sphere, how many that we will find. For that, what you have to do is you have to calculate molar mass of silver chloride, and this molar mass of silver chloride is around 143.3. Okay. Therefore, we know that when we are getting 143 grams, means how much, how many ml it is being taken, it corresponds to how much, we will see that one. So 100 ml of 0.1 molar complex solution is taken. Okay. Now 100 ml 0.1 molar means the amount of complex present in the solution turns out to be how much? 0.01 mole. Okay. In 0.1 molar 100 ml solution, we will be having 0.01 mole of what? Complex. So now AgCl found is how much? 2.86 gram. See here, 2.86 gram. Okay. So 143.3. So therefore, when I shift the 2 digits here, what it turns out to be? 1.433 grams of AgCl. Okay. So now, so that is 0.01 mole. If I take AgCl, it will be 1.433 grams of AgCl it will be. Okay. But how much you are getting? 2.86 grams. So therefore 2.86 means, just if you multiply this with 2, okay, 2.86 gram, then what happens? Here also you have to multiply 2. So therefore it turns out to be 0.02 molar. Okay. But your solution taken is 0.01 mole, but you are getting 0.02 moles of AgCl, meaning is what? So in the ionization sphere, there are 2 chloride ions. So therefore your option is C option. Okay. So this is how you have to approach the solution of this problem. Okay, so let us move on to the next question. Coordination sphere, here bromide is outside the coordination sphere or it is present in ionization sphere. So therefore, what is the relationship between these two complexes it is being asked? Okay, your option is A option coordination isomer, B is geometrical isomer, C optical isomer, D is ionization isomer. Because when you subject these two or if you dissolve these two in water, one will furnish bromide ion, another will furnish sulfate ion. So therefore, the relationship between these two will be what? Ionization isomer. So therefore, your option is D option, which is ionization isomer. Okay. Okay. The next question is, which of the following statements are true about cobalt F6? Okay, -3 ion. 36th question. Which of the following statements are true with respect to this complex it is being given? Okay, first thing is I will explain what it is, then we will go through the options and then we will be able to identifying that one. It's a weak ligand field, and first thing you should make note that it is going to form outer orbital complex. Outer orbital complex by using what? sp3d2 orbitals. And second important thing is, as it forms outer orbital complex, your D will be having what? Unpaired electrons, so therefore it is paramagnetic in nature. Paramagnetic. Okay. And the charge on the cobalt will be +3. So these are the three factors you make note of this. And then we will see the options what it is being given. The first statement is the complex has octahedral geometry. Okay, it is true. Okay, second one is coordination number of cobalt is 3 and oxidation state is +6. Okay, and the third option is the complex is sp3d2 hybridized, and fourth option it is high spin complex because it is paramagnetic, because more number of unpaired electrons are there. So therefore your wrong statement is second statement, that is coordination number of cobalt is 3. No, it is 6. Okay, and oxidation state is +3, but here it is given as what? 6 + 6. So therefore the statement 2 is wrong. So therefore in the given option A is given as 1, 2 and 4. Your right option is this one. The second option what I have said, coordination number of cobalt is 3 and oxidation state is +6, it is wrong, and all other statements are correct. That is 1, 3 and 4 statements are right. So therefore your option is B in a 36th question. Okay, let us move on to the next question. 37th question. Okay, just I will read the question, please go through this. A haloalkane undergoes SN2 or SN1 reaction depending on, okay, the mechanism followed by the reaction. Okay, either it is nucleophilic substitution unimolecular or nucleophilic substitution bimolecular. That depends upon what it is being asked. And your options given are, so what is the question? Haloalkane undergoes SN1 or SN2 reaction depending on what factor it is given. See here, among all the 4 factors what are being given here, okay, so we cannot say that any one of the option from this is more relevant, okay, but in the given only we have to identify and we should tell that one, because solvent used in the reaction, of course it is going to decide SN1 or SN2 to small extent, we can say. Okay, then next is low temperature, nothing to do with the temperature for SN1 or SN2 mechanism to be followed by the reaction. And the third option is type of halogen atom, bromo, chloro, that doesn't make any difference. So or it is not having any influence to make the reaction either SN1 or SN2. And third option is stability of haloalkane. Okay, it is nothing to do with the stability of the haloalkane. The exact what we can say is it depends upon what the either the haloalkane is primary, secondary or tertiary. It is going to depend upon that, and that option is not given. In the given options, the more appropriate is that solvent used in the reaction, okay, is going to decide either SN1 or SN2 mechanism. So therefore your option is A option. Okay. 2-methyl propane can be prepared by Wurtz reaction. Okay, so what is that? 2-methyl propane. So this is the target compound. Okay, prepared by Wurtz reaction, the haloalkanes taken along with metallic sodium and dry ether. Okay, what type of haloalkane you have to use to get this product? Okay, so the given options we will write. Make it as what? Haloalkane 1 and 2 plus sodium metal, dry ether, okay, to form 2-methyl propane as the product. So what this two haloalkanes we are supposed to take, okay, to get 2-methyl propane as an product. Okay, so options given are, so what do you want? You want to prepare 2-methyl propane. So therefore what you have to take is, you take CH3 CHCl CH3 plus sodium metal plus ClCH3. Okay, so then you will be getting what? CH3 CHCH3 CS3 as your product. So therefore what is that option? Chloromethane and 2-chloropropane, that is option A. Okay, and another thing you should make note of this, which may be helpful for other examinations. See here, when you take mixed haloalkanes, generally we will get mixtures. Okay, mixtures of alkanes we are ending with, but among those, if you want to prepare it as it is specifically asked in the question, that to get 2-methyl propane, we have to use these two reagent as haloalkanes to get that one by Wurtz reaction. Okay, next move on to the next question. The first thing is, first reaction is halogen exchange reaction. Okay, that halogen exchange we can bring by silver fluoride, mercury fluoride and cobalt fluoride. Okay, so therefore your second option here only we can eliminate. And the second one is, here it is dehydrohalogenation. So dehydrohalogenation. So therefore that we can bring by alcoholic KOH. So therefore, of course, again it is in this one option. So therefore second already we have eliminated. And the third one is, that is, it's a Wurtz reaction. Wurtz reaction where C2H5 is going to combine to give C4H10. So therefore, your option number A, option D also get cancels, and your right option is what? C option. Okay, so this is how you have to find the answer for such question. Fine. So let us move on to the next question. Okay, let us go into this. 8.8 gram of monohydric alcohol added to ethyl magnesium iodide in ether liberates 2240 cubic centimeter of ethane gas at standard temperature and pressure. This monohydric alcohol, when oxidized using PCC, forms carbonyl compound, and that answers for silver mirror test. The monohydric alcohol is, okay, so the following options are given. So one thing you should remember, when that alcohol is oxidized with PCC, you are going to get carbonyl compound. That carbonyl will be either ketone or aldehyde. Okay, and either it is ketone or aldehyde, that we can identify by using silver mirror test. Silver mirror test is given by only aldehydes because terminal carbonyl group is there in that. Okay, so therefore we can eliminate two answers, that is butane 2-all. Okay, so terminally, if you want aldehyde group, means we need a hydroxy group at the terminal carbon atom. So therefore 2-all means it is not terminal hydroxy group containing compound. And your D option, C option, so that also we have to eliminate, and it will be between these two, B and C, and among those how it is, so that we can see from the first part of the question. See here, 8.8 gram. Okay, as it is giving gas how much? 2240 cubic centimeter. Okay, so now suppose if it corresponds to 0.1 mole. Okay, because we know that 1 mole of gas at STP STP is 2000 to 22,400 cubic centimeters. Okay, we must know that one. And here it is given 2240, means it is 0.1 mole. So therefore, its molar mass of the compound will be what? Right? 88 grams. Okay, per mole. So therefore, among these two compounds, okay, so which will give that 88 grams per mole. So that will be our answer. So let us write B option first. Okay, 2,2-dimethyl. Okay, 2,2-dimethyl propan 1-ol. Propan 1-ol. Okay, so that we will write OH, CH3, CS3. Okay, how many carbon atoms? 1, 2, 3, 4, 5. So therefore, 5 into 12 plus then number of hydrogen atoms 3 plus 3 plus 3, 9 plus 2, 10, 11 and 12. So therefore 1 into 12, and then oxygen is 16. So it comes out to be 88. So therefore 88 grams. Then your option is B option is the correct option. Okay, so that is how we have to approach this question. Fine. So let us move on to the next question. That question number 41 is, when tertiary alcohol A, C4H10O, okay, reacts with 20% H3PO4, okay, at 358 Kelvin. Okay, so the compound, it is going to give B compound, which is having molecular formula C4H8 as the major product. Okay, so then the IUPAC name of that compound is being asked, compound B. Okay, so the options are given. So it is a tertiary alcohol. Okay, CH3, CH3OH. Then what it is being done? By using phosphoric acid. Okay, 20% phosphoric acid is used, and it is heated at 354 Kelvin. So then you are going to get the product. It's a tertiary alcohol with the molecular formula this C4H10, means this is the formula what we can find for that. And it is going to give C4H8, means CH3, CH double bond CH2, CS3. So this is the product what we are going to get. Okay, so here the proton is accepted by this, and there is a dehydration will takes place. Okay, leading to the acquiring of double bond. So as it acquires double bond, you see here how you have to count the numbers 1, 2, 3. So therefore it is 2-methyl propan 1-ene. Okay, 2-methyl propene you can write, or 1 is not required because it is containing only 3 carbon atoms. You can write propene. Okay, let us see the options. Option A. Okay, so your option is D. Okay, so let us move on to the next question, that is 42nd question. Okay, here only we will write PCC is. Okay, so option number 1, potassium dichromate plus pyridine. B option, chromic acid plus chloroform. C option, chromic acid plus sulfuric acid. And D option is a complex of chromium trioxide with pyridine and HCl. And your right option is D option, that is, it is a mixture of chromium trioxide with pyridine and HCl. Okay, and this reagent is used to bring the controlled oxidation of alcohol to form the aldehyde. Okay, so when you use potassium permanganate or potassium dichromate, oxidation will end up with aldehydes as well as your carboxylic acids. Okay, whereas when you use this PCC. So then it is going to do, or the oxidation will stop at aldehyde only or ketone only. Okay. So if you use primary alcohol, you will be getting aldehydes. If you use secondary alcohol, you will be getting ketones. Okay, with this reagent. Fine. So this is all about 42nd question. So let us move on to the 43rd question. 43, question number 43. Propanone and propanal are, okay, I will write both the structures. CH3, C double bond O CS3, CS3, CS2, CHO. Okay, so what difference make out between these two? So one is aldehyde, another one is ketone. Molecular formula is in both the cases same. Only functional group is going to differ. So therefore, I will read out the options. It is a position isomer, A option, B functional isomer, C chain isomer, D geometrical isomer. Your answer is B. So that is functional isomers. Okay. The next question, number 44. Okay. Sodium ethanoate. Okay. Sodium ethanoate. Question number 44. C2H5 ONA plus minus. Upon heating with soda lime, NaOH CaO. Okay. Gives compound X. Okay. And same sodium ethanoate, when it is subjected to electrolysis, okay, it gives product Y. Then what is the X and Y is being asked. Okay, options we will see. The first option is the answer, just we will find it out. So when you subject this sodium ethanoate, when you treat with soda lime, so then what happens? It will undergo first oxidation to form, so it is going to convert into carboxylate, and that carboxylate undergoes decarboxylation to give methane gas. Okay. Similarly, here it is Cope's reaction. You should remember Cope's reaction. Just you remember this one. So here what happens? C2 CH3 COO Na you will be having. Okay. This converts like this, and 2 moles of this are going to undergo electrolysis to give carbon dioxide is eliminated, and you will be getting CH3 as the product. So therefore your right option is A, that is methane and ethane. Okay. So let us move on to the next question, that is 45th question. But 1-ine. Okay. I will write the structure. CH3 CH2 C triple bond CH. Okay. On reaction with dilute sulfuric acid in presence of Hg plus 2, in presence of butane, upon reacting with dilute H2SO4 in presence of Hg plus 2 salt, okay, ions at 333 Kelvin. What is your product? It is being asked. Okay. So generally what you are going to get, it is going to form CH3 CH2 COH OH 1,1 diol means 2,2 diol. Okay. So CH3 we will have. Now this undergoes what? Dehydration, and to give CH3 CH2 C double bond O CH3. Now we will see the options. A. So what is the right option? Already I have written the structure here. Okay. So this is the structure of the compound. So therefore your right option is A option. Okay. Then 46th question. biologically active adrenaline, ephedrine used to increase blood pressure contains. Okay, so primary amine group, secondary amine group, tertiary amino group, quaternary ammonium salt group. So 46th question. What is the question? Biologically active adrenaline and ephedrine used to increase blood pressure contains A. Primary amino group, B. Secondary amino group, C. Tertiary amino group, D is quaternary ammonium salt. Your right option is B, that is secondary amino group. Okay. The next question is in the reaction. Okay. 47th question. In the reaction, aniline. Okay. NaNO2, sodium nitrate, dilute HCl. Okay. It gives P, and P upon treating with phenol. Okay. In presence of NaOH. So what it is going to form as Q. So options given are A. And your right option is, we will write the product and we will understand this one. Okay. So what you will be getting? N double bond N. Here it is plus and minus charge. Okay. Diazonium salt we are going to get. And this upon treating with phenol, what you are going to get? At para position, your product will be, okay, like this you are going to get the product. N double bond N. Hydroxy group. So therefore your right option is B or C option, that is para-hydroxy azobenzene. Okay. So that is the product what we have to obtain. Fine. The next question is 48th question. Again it is out of syllabus. It is from chemistry. Your chapter, that is chemistry from everyday life, which is being excluded. But still it is given the female sex hormone which is responsible for the development of secondary female characteristics and participates in control of menstrual cycle. Okay. So this question is out of syllabus. We will not go with that in detail. Fine. 48th question is out of syllabus. Make note of this. The next question, 49th question. The type of linkage present between nucleotide. 49th question I am talking. Okay. The type of linkage present between nucleotide is phosphoester linkage, phosphodiester linkage, amide linkage, glycosidic linkage. Your right option is B option, that is phosphodiester linkage. Okay. The next 50th question. Alpha D plus glucose and beta D plus glucose, okay, are enantiomers, conformers, epimers, anomers. Okay. So in both the cases where they are going to differ, they differ in the position. Alpha and beta are going to represent the configuration of the carbon number 1 in cyclic glucose. Okay. So in carbon number 1, it is on a hydroxy group. If it is on the right side, so then it is called alpha. If it is on the left side, it is called beta. So therefore both are called as what? Anomers. And your option of 50th question is, that is your D option, that is anomers. Question number 51, it is on polymers. Okay. So that is also out of syllabus, right? And 56, second question, the biodegradable polymer obtained by polymerization of glycine. Again, it is on polymer. Okay, this is also out of syllabus, we can say. And 53rd question is, okay, it is given phthalimide, and its options are relevant. It is also again out of syllabus. This comes in your chemistry in everyday life. Okay. And your 54th question, again this comes from your what you call cationic detergent. It is also from chemistry from everyday life. So therefore all these questions are out of syllabus. Okay. So we will see what is going to happen with these questions, what they will do, right? I hope you have attended all the questions. Right. 55th question we will take. For which one of the following mixtures the composition is homogeneous, uniform throughout it is given. Uniform throughout meaning is what? Homogeneous mixture. Therefore, we will see the options. Sand and water, again it is heterogeneous. Grains and pulses with stones, okay, it is not uniform throughout. And mixture of oil and water, they won't mix, that is immiscible with one another. And your D option is 55th question. Question is, for which one of the following mixture is composition uniform throughout? Okay, your option is D option, that is dilute aqueous solution of sugar. Okay, dilute aqueous solution of sugar is what? Uniform throughout. Okay, you cannot differentiate between sugar and water. Okay, so therefore it is a homogeneous one. Answer is D. Okay, then 56th question. The energy associated with the first orbit of helium plus, first orbit of helium plus, n is equal to 1. Okay, and it is being calculated with the formula 13.6 z square by n square ev. You will be getting answer, and thus that if you multiply with 1.69 into 10 to the power minus 19, okay, so you will be getting answer in terms of what? Joules, and that answer turns out to be how much? Minus 8.72 into 10 to the power minus 18 joules. Okay, your option is B option. Okay, a metalloid is metalloid, neither it is metal or non-metal are called as metalloids, and you are given with bismuth, okay, antimony, phosphorus and selenium, and in the given option your antimony, that is SB. A option is question number 57. A option is bismuth, B option is antimony, and C is phosphorus, D is selenium. So therefore option is B. Okay, phosphorus is non-metal, again selenium is also non-metal, bismuth is metal. So therefore you are in the given option, SB is the what? Metalloid. Next, 58th question. A pair of isoelectronic species having bond order of 1, bond order, okay, all are isoelectronic given pairs, and in that you are just asked to identify bond order 1 in both the cases. Okay, so we'll see one by one. Option A is N2CO. Here bond order is what? 3. B N2NO plus. Again here also bond order is 3. C option O2 minus 2 and F2. Both are having 18, so therefore isoelectronic, and its bond order is found to be 1. Okay, and D option is carbon monoxide and NO plus. Again here also we find bond order as 3, so therefore your option is C option for 58th question. Okay, 59th question is, again it is from states of matter. Sorry, it is from yes, states of matter, right? And it is also out of syllabus, right? Then last question, that is 60th question, is from the diagram. Okay, this diagram is okay. So what they have asked, enthalpy of reaction for the reaction C to A they have asked. Okay, so both I will answer. If it is, see here, A to 2B, 2B to C, plus 10 plus 25 turns out to be plus 35 joules, right? Now, if it is from A to C, then it is plus 35 joules. But it is, as it is from C to A, means it is a reverse reaction, so therefore it will be minus 35 joules. Okay, so we will see the options. A plus 35 joules, B minus 15 joules, C minus 35 joules, D plus 15 joules. Okay, your right option is Hess's law. What it says, either you bring the reaction in single step or in multiple step, the change in enthalpy of the reaction will be same. So therefore 10 plus 25, it will be 35. So therefore directly A to C, if you prepare, so then it should be plus 35, but we are preparing C to A, means the sign will change of enthalpy of reaction. So therefore your enthalpy of reaction is minus 35 joules, and your right option is C option. Okay, so by this I hope we have gone through all the questions except which are out of syllabus. Okay, thank you for watching and share with your friends. Okay, thank you.